Hello and welcome everyone. I'm going to talk about forecasting social economical impacts using conflict data. My name is Borbála Farkas and I work as a research engineer at Views. So let me introduce the core problem. So there is a mismatch in data that we use in early warning systems. So on one hand, we have the conflict data, like UCDP or ACLED, which comes in a very high resolution, usually monthly resolution, and it's updated frequently. But when it comes to understanding its consequences, then we often face a delay problem. Because the social and economic indicators are typically reported annually. So, and not only this, but there is usually a significant lag in these indicators. So it means that when we observe these indicators, then the actual event there was a long time that the actual event has passed. So we observed the conflict quickly, but we observed its consequences very slowly. So far, we couldn't manage to solve this problem to translate conflict prediction into the social economical impacts. But what if we could do forecasts on impacts of conflict? So, if we think about this problem, we just have this question naturally. What is the next step? What is missing? Because we already have very good forecast, conflict forecasting. So what we usually miss is the next step. And the next step is how it changed people's lives. And we can think about this missing link as three terms, three impact domains. One is health, which includes infant mortality and life expectancy and other indicators. The other is economy, with indicators like GDP per capita. And we also have society with indicators like liberal democracy. So the goal is to forecast social economical impacts and not only conflict forecasting. So the core idea is conceptually relatively simple. We start from the conflict data, which is observed monthly, and then instead of trying to derive social economical forecast directly from conflict data, we use a model, which is in our case, it's a deep learning time series model, which tries to learn the pattern and the relations between conflict and its impacts. And then, in this sense, we can do this. We can translate these impacts with a data-driven way. So the pipeline. Let me introduce the pipeline. We start with the input, which is conflict data with monthly resolution and indicators with annual resolution. And then we have the model. And then here is the catch. So instead of doing only one forecast, we actually do two separate forecasts. One is our observed world with the previously mentioned impact domains. And the other one is a no-conflict world, a counterfactual world, which means that what would happen and how would it look like if we hadn't had conflict. And then we have these different forecasts, and we can actually combine them and define the impact, which is the difference between forecast and counterfactual. And now we have this impact. So, but we immediately face a technical challenge when we try to implement this. So this problem is that we need to bridge timescales that are not on the same scales. So we have the annual indicator, GDP per capita or infant mortality rates, but we cannot just directly insert it in our pipeline. So our solution is twofold. So first, we need to temporarily disaggregate these annual data. And then we are doing a nowcasting, since it's not only annual, but also delayed. So we first have to do a nowcasting to have the missing data. And then the model learns the monthly conflict dynamics, and we do a 36 months forecast horizon monthly forecast. So let me show you an example. Ukraine, and the indicator is GDP per capita. So here you can see the whole time period with the recent conflict in 2022. And with darker green, you see our forecast, conflict forecast here. But what is interesting is the red and orange forecast. The red is the actual observed world forecast, and the orange is the counterfactual world. And we see that they diverge. And the gap here is actually the impact that we defined previously. So I'm going to show another figure, this one, because in this you can see the impact better. So this shows the impact as a percentage in terms of the counterfactuals. And it tells how much the GDP per capita changes compared to the no conflict scenario. And when we have this, we can actually expand this framework and apply this framework to other indicators. As it was mentioned yesterday, in one of the panels, Howard Hegre mentioned that we also do infant mortality rates. So this is another figure about infant mortality. It shows the absolute infant mortality, so how many children would die due to conflict. And then we get the terrifying number of 500,000 in our forecasting horizon. So, all right. So far we talked about the methodology and some examples. But the real question is, why do we do this? And who's going to use it? And the answer is decision making. So decision makers often need to know how the impact of so how these social and economical impacts of conflict changes based on different scenarios. So for humanitarian organizations, it usually means that the anticipation of mortality and food insecurity, or identifying high-risk population. But for development actors, impact modeling can help quantifying economic and human losses and allocating resourcing to high-risk regions. And since we do explicitly counterfactuals, so different scenarios, it's also useful for policy making. So we can analyze different policy scenarios. For example, escalation versus de-escalation pathways, or evaluate different policy trajectories. But I have to tell that there are some limitations. So first, this uncertainty. So conflict forecast has an uncertainty, and of course it propagates to this impact forecasting. And it accumulates and amplifies with the forecasting horizon. And there is the counterfactual construction, how we create counterfactuals. So we used a very simple no conflict scenario, but the question is it really the right way to make baseline, the appropriate baseline model for impact? And then obviously the data limitation, that the data is low resolution and delayed, and that we mostly is resolved by temporal disaggregation and nowcasting, but it also has some uncertainty that we have to address. And finally, the validation, which is more complicated because of the process, the complexity of the process, and the sparse data. So I have to emphasize that this is still an active research problem. Okay, finally, let me tell three take-home message. So one is that we could manage to translate conflict forecast into social economical forecast, and then this provides an earlier information than conventional indicators, and then the third one is that it helps and supports the work of decision makers. Thank you for your attention.